In this circuit, the switch has been at position A up here for a long time. At time t equals 0, it moves in this direction indicated by this arrow and ends up at position B. We want to find this current through the inductor at t equals 0 minus, t equals 0 plus, and as t goes to infinity. At t equals 0 minus, the switch is at position A. And it's been at A for a long time. The input is 6 volts, it's constant. For constant inputs, after a long time, the inductor current will have become constant and the inductor voltage will be 0. That means the inductor looks like a short circuit. The resulting circuit looks like this. There's a 6-volt source, a 2 ohm resistor, a 3 ohm resistor, and the inductor, which is represented by a short circuit with no voltage difference across it. So this is I at 0 minus. Since this is a short circuit, there's 0 voltage difference across that. This is in parallel with this 3 ohm resistor, so the 3 ohm resistor also has 0 volt difference, so there's no current going through that resistor. That means that the current through this inductor is the same as the current out of the source, which will be 6 volts over 2 ohms, or 3 amps. At t equals 0 plus, to get the inductor current, we rely on the fact that an inductor cannot change its current instantly. That means that the current at 0 plus is going to be the same as the current at 0 minus, which is 3 amps. Finally, as t goes to infinity, the switch has been at position B for a long time. The input to the inductor is 4 amps and it's a constant value. Under these circumstances, the inductor again behaves like a short. So the appropriate circuit is to have the inductor look like a short circuit. This current is I of infinity. There's a 12 ohm resistor, a 4 amp source, and a 4 ohm resistor. Since this is a short, this becomes all one node. The 12 ohm resistor and the 4 ohm resistor are in parallel. I know the current going into a parallel combination. I want the current through one of the resistors, so that looks like a perfect application for a current divider. And I at infinity is the total current, 4 amps, times the other resistance, 4 ohms, over the sum of the two resistances, 4 ohms plus 12 ohms. That's 1/4 of 4 amps, so I at infinity is equal to 1 amp.